Hello, in this video, we're going to try to find the sum of the first n natural numbers. So the problem we're trying to solve is the summation from I equals 1 to n of I. And what we want to try to do is find some formula that's going to give us the result of the summation without actually having to compute it by hand. So what I want to consider is the partial sum. So the sum of the first n terms in this series. Let's let that be denoted by S sub n. It's going to be 1 plus 2 plus 3 plus dot 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 plus n minus 2 plus n minus 1 plus n. And so what we're actually going to do is we're going to add this partial sum to itself. But what we're going to do is that we're going to reverse the order of the terms in the partial sum. So n will come first and 1 will come last. And we're allowed to do this because this is a partial sum, so that means it has a finite number of terms. You might be familiar if you've taken Calculus 2 about the result of the Riemann rearrangement theorem, and you know that in the infinite case that commutativity of addition does not necessarily always hold. However, we have a finite number of terms, and so we have no issue applying the commutative law of addition, and that's what we're going to do here. So, if we add S sub n to itself, but reverse the order of this second S sub n, that means that n comes first. It's going to be n plus n minus 1. Oh, it's supposed to be a 1 there. N minus 1 plus n minus 2 plus dot 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 3 plus 2 plus 1. And I had to write a little small and try to squeeze it in there, but this n is paired with this 1. This n minus 1 is paired with this 2. N minus 2 with 3, etc. And so we have an even pairing across these columns. And so when we add these series up, what we're going to get is that we have n plus 1 by adding 1 and n. We get another copy of n plus 1 by adding 2 and n minus 1. We get another copy of n plus 1 by adding 3 and n minus 2. And this pattern is going to continue for however many pairs of terms we have in the sum. So pattern will continue. We see here we have n minus 2 and 3. That's going to be n plus 1. N minus 1 and 2. That's n plus 1. And n plus 1 obviously is n plus 1. And so just by changing the order in which we add these terms, we've made it such that the sum of the columns of this collection of sums, I guess you could say, produces n copies of n plus 1. And so our left-hand side is 2s sub n, because we added s sub n to s sub n, and our right-hand side is n times n plus 1. Because remember, s sub n is representative of the sum of the first n natural numbers, so we have n terms. That means that by adding s sub n to itself, we've produced n copies of n plus 1. And to find the formula for s sub n, all we have to do is a little bit of algebraic rearrangement, divide out by 2, and we get that s sub n is equal to 1/2 n plus 1. So that's the formula for the sum of the first n natural numbers. This will hold for any arbitrary argument of n. I hope this video is helpful, and that's it.